So, in this video we're going to be looking at working with variables, and I've added a notes tab so I can take some notes. So that you can follow along and have some notes as well. We're going to be looking at naming variables, creating variables, and then using variables. And we're also going to be looking at using the variables that we create in the calculator application in the graphing application of the calculator, so we can also start to become familiar with how to use that application of the calculator as well. So first of all, when naming variables, there are a couple of rules that we need to follow. First of all, variables can be 1 to 16 characters long. They can be made up of letters, digits, and the underscore character, which is this character here. Spaces are not allowed. Secondly, the T-Inspire calculator series doesn't distinguish between capital letters and small letters. So if you have a variable that's called NUM, then if you type NUM, the calculator thinks that's exactly the same thing. So if I just summarize that, doesn't distinguish between capital and lowercase letters. The first character can't be a digit. So we should start with a letter, and if you start with an underscore, it means it's a unit. So I would recommend starting with a letter for all of your standard variables. And also standard command names or functions can't be used because those names have already been given. So for example, if you tried to put in answer or cos for cosine, the calculator will return you an error because it already has those things stored within it, and you can't then save other things to those variables. So no names that have already been used can be used for your variables that you define yourselves. So just a few things to remember there, and shouldn't take too long to get used to. So let's have a look first of all at storing a new variable. Now you might ask why we need to create variables. And there are a couple of reasons why you might want to store a variable. As of an example, let's say you wanted to solve the quadratic equation x squared minus x minus 1 is equal to 0 for the variable x. You'll see here that we have two different solutions, and they're quite long solutions. So let's say we wanted to store one of these as a variable because we want to use it again and again and again. So I have this expression here, which I can just copy. And there are a couple of ways I can store this number to use later if it's something that I'm going to need a lot. So I can put this expression or number in, then I can press Control and var for variable, and you'll see that brings up the STO function that's storing the variable. And then I can put in, let's call it num for number. And now if I just type num in and press enter, it returns this number here. I can also type in num and press Control, enter, and then get an approximation. So we can store numbers in variables, and this is what's done every time you do a calculation with the answer variable. We've already met an important variable in the calculator, the answer variable, which returns the last expression that you got as an answer. So the answer variable is constantly updated, whereas your number variable that you will have just defined here, that's something that you've defined and stays exactly the same every time. So I can do, for example, if I wanted to do number squared plus number minus 1, then it returns that for me. And if I change this to a minus, I could check that I get 0 back out. Number squared minus number minus 1. Then I get 0, and I can check that yes, that in fact does solve that equation. So it's a nice way of storing long numbers or big numbers. But that's not the most important use of variables. However, before we move on to our next use, I want to show you just a different way of storing variables. So we have expression, then our store arrow, and then the name, and that stores the variable. You can also use this colon equals here, but then we have to do things the other way around. So if I had the variable num2, I've taken the name first, then I press Control and then the vector menu or expression menu to bring up this colon and equals, and then let's say I want to store this solution this time, and I press Enter, and then it just returns this. So now if I type num2, it will return this number for me again. So we have these two ways of defining variables. You can also do it through the menu function. If you go Menu, Actions, Define, then you put in the name, let's say num3, then you put in equals, and let's say we want num3 to be 2.03. You press Enter, the calculator returns done, and then if I put in num3, I can then return that variable, or as I've done above, I can also do calculations using that variable. So we have three different ways, with the store arrow, with the colon equals here, and through the define operation in the menu. We can just store these variables three ways. We can store numbers as we've seen, and then we can use those numbers in expressions to calculate with larger numbers, for example. But a really nice thing that we can do is define functions in this way. So if I take my define way, let's say I would like to define a function that will give me the area of a circle. So I'm going to call this variable area underscore circle, and then this variable will need to take the argument r, because I'm going to need to put something in each time. I'll put equals, the area of a circle is pi times r squared, and then that's done. Now what I can do is I can put in any value for r, and I can evaluate this function at any value. So I could now write area underscore circle, brackets, and if I say that my circle has radius r equals 2, then it gives me that the area of that circle would be 4 pi, or with Control Enter, it will give me that the area of the circle is 12.57 to 2 decimal places. And then I could do area underscore circle, let's say num. So if I want the area of the circle of radius number above here, which actually is a negative number, but which seems a little bit strange. Let's go for num2, the positive one. Then it gives me this expression, so I can build variables upon each other. So I can define a function as long as I have the variable name, I open a bracket and I put the argument in here, and I close the bracket, and then I give an expression with that argument. And you can use that if, for example, you wanted to create a table of values. You could define a function. So let's say we wanted to use a different way of storing a variable. Let's say your function was x squared minus 2x plus 1, and we store that using the control store function. Oops, coming to the end of my expression, control store, and I store that as f of x. It returns done again. Then if I wanted to create my table of values, I can just type in f of, let's say, -3 to start with, f of -2, f of -1, etc., etc. And then it will just return the y values for my table of values if I wanted to have the table of values for this function between -3 and, say, 3, for example. So you can also define functions in this way. However, functions don't just need to have one argument. So far we've had two. We've had the area of the circle, dependent on the radius of the circle r. We've had f of x, dependent on the number that you put in for x. Sometimes, though, we have expressions that are dependent on more than one quantity. For example, if I wanted to have the surface area of a cylinder, I could name my variable surface area sil, the cylinder. That would be dependent on the radius of the circle at the base of the cylinder and the height of the cylinder, h. Then I can store that variable using this function here. And I could say that that is equal to 2 pi times r squared for the base of the circle plus 2 pi times r times h for the curved surface area of the cylinder. If I press enter, that says then it's done. Now, if I wanted to find the surface area of a cylinder, and you'll notice it goes bold and changes from italics to normal text once it recognizes the variable name, of a cylinder that had radius 3 and height 5, then I can just put those arguments instead of r and h into here, press enter, and it tells me that the surface area of that cylinder is 48 pi, or, as a decimal, 150.80, for example. So I've recorded a couple of different variables, and I've also defined some functions using the variable things. If I want to recall a variable at any time, I can just type the variable name and press enter. I can evaluate a variable by saying area underscore circle 2, or let's have a new number 5, like I've done before. And I can also graph functions that I've defined as variables. So I'll need to add a new page, so I'll insert a graphs page. And I can say f of 1 of x would be equal to area underscore circle, and you'll see it recognizes it. And this time my argument needs to be x. Because we work in the variables x and y within the graphing section, you need to have x. R wouldn't work because it wouldn't understand what r was. And I press enter, and it draws me a graph of the area of a circle. So I can then read off, if I have a circle that has a larger radius, I can see that the area gets much, much larger. So I can also graph functions that I've defined as variables within the calculator application. And this works as long as you type exactly the same names in within the same problem. If though I added, for example, not under menu, document, insert problem rather than page, I added a calculator one, you'll see that this tab is now called 2.1, and these all are 1 point something. That's then defined as a different problem, and then my variables such as area underscore circle then aren't recognized within that problem. So variables work within the same problem, and then you can use the same name again if you want to in a different problem. The final thing I wanted to show you is how to delete a variable. So if I wanted to delete this variable area underscore circle, I would go menu, actions, delete variable, then I'd type in the name, area underscore circle, press enter, done. And then you'll notice that if I type that in, it doesn't recognize it as a variable anymore. But you should be sure if you want to delete a variable, because it's one of the few actions within the calculator that can't be undone.